sdm4 Chapter 26 focuses on analysis of variance. In a nutshell, analysis of variance is like a t-test that lets us compare more than two groups. It makes an equal variance assumption, but that's one of the costs you have from this. So this is overall going to be pretty similar to what we've seen before. There are a couple of new things I just want to highlight as we proceed. So we can test whether or not the means of several groups are equal, and we actually get two different examples here that are laid out. And the question is how different they are and what kind of ruler we could use to make those comparisons. If we think about observing a table of means and standard deviations, that might be useful to kind of see how different things are overall. There's something called the F statistic. This is an analog to the T statistic, but with more than two groups. It has two things that control its degrees of freedom, a numerator or denominator, or a model and error. And it's something associated with that called the Anova Table that's controlled by these degrees of freedom. There are lots of constraints in this table, and there's lots you want to be thinking about how to decompose the total sums of squares to kind of generate the sums of squares, to see what part are from the model, what part is residual. The first here with 3 degrees of freedom, the second with 28. So these examples kind of help step things out. We see the F table. We won't be looking it up like your parents did. We'll be using PF as a way of doing that as a function in R. And we can go ahead now and see how this decomposition works and what the formalization is of the Anova model. So we can kind of think about pulling things off from parts and parts. That's what's going on in that section. It's worthwhile to kind of review that for a particular example. And then always, as always, thinking about the assumptions and conditions needed. And here we do have this equal variance assumption that we need to make in this situation, as well as the other assumptions. So we can think here with a think, show, and tell that actually steps us through an example and how we actually compare means. One of the things that's a little bit more complicated here, because we have more than two means, is there's as many more pairwise comparisons possible. This moves us into something called multiplicity adjustment, and we think here about the Bonferroni procedure as one approach to address that. There are many other ones. One of them is this the minimum significant difference method due to Tukey, and we can think about other things in terms of ANOVA on observational data where we might not have equal sample sizes. So we have another think, show, tell to kind of close out the section. Lots of areas where we actually where things can go wrong, particularly in terms of multiple comparisons and learning objectives. Not a whole lot new here in this section. We read in the data. We look at a BW plot, a box and whisker plot of these data, and we can go ahead and kind of see. Fave stats is nice. Y by X actually gives us the summary statistics. We can see here the calculation of P of F values using, here in this case, 3 and 28 degrees of freedom. That's what that looks like. And then in a situation where we can actually fit a linear model for this, we get an overall F statistic, and this is really coming together from that from the F procedure. So in a nutshell, ANOVA is really doing inferences when we have 3 or more groups.